children. How are you? My name is Sebastian, the sock puppet. Yeah.
And I'm Santiago.
And I'm also Sebastian.
And we're here to teach you about sine graphs today. I'm going to ask my good friend Santiago over there to hold up an example of a basic sine graph. Okay, children, so this is a basic sine graph. First, we'll look at the period of the graph. The period is 2 pi, which means the graph starts at 0, 0 and ends at 2 pi. So the total distance of the graph is a total of 2 pi. The range of the graph is -1 to 1, which can be written as -1 is less than or equal to y, which is less than or equal to 1. Isn't that amazing? Yeah! Okay, and another thing on this graph is the equation. The equation is y is equal to d plus a sine parentheses bx minus c. Okay, so let's take that graph down, Santiago, and we'll take a look at an example problem. Oh, hey, Sebastian, how are you?
Oh, hey, Sebastian.
Oh, that's your eye. It just fell.
Dang it.
Okay,
That's
see
a
ya.
bummer.
See ya, go get that fixed. Okay, anyways, here's our example problem. Okay, so our example problem is y is equal to 1/2 sine x minus pi over 2. So we have transformations going on in this problem. The first transformation is a vertical transformation. So instead of our y's being 1 and -1, they're going to be 1/2 and -1/2. Isn't that fascinating, Santiago? Okay, well, looking at the x values now, the x values are now going to move to the right pi over 2. So instead of starting at 0, 0, the graph is going to start at -pi over 2. And then it will go through its entire cycle and end at the pi or 2 pi period, just like the other graphs. Okay, let's take that down now. So next we're going to be talking about cosine graphs. Yay! Yeah! Okay. So the cosine graph is very similar to the sine graphs. It also has a period of 2 pi, and its range is also -1 to 1. Yeah. And look at this! Santiago, what letter does this graph look like to you? That's right, a W, which happens to be our letter of the day today. It's a W! Yay! Okay, let's take that down now. Thanks, Santiago. Here's an example problem we can do for the cosine graph. Hey, look, if we flip this upside down, what letter does it look like? A W. Ah, that's our letter of the day. Okay, pick that up, Santiago. Alright, so our example problem is 3 cosine parentheses x plus pi. So, we again have 2 different transformations going on, a vertical and a horizontal. Let's look at the vertical first. So instead of starting at not starting, but having the y values of 1 and -1, we're going to have 3 and -3, just like this on the graph. Oh, hey, Sebastian.
Oh, hey, Sebastian.
What's wrong with your eye? Did you get it fixed? Okay, see ya. Alright, and so the other one is a horizontal shift. So we're going to move to the left pi. So instead of starting at 0, 0, or starting at the x value of 0, we'll be starting at the x value of -pi. Alright, so there you go. That's your example problem for that one. And so a couple other little things about sine and cosine graphs. The sine graph continues on in every direction forever. This also goes for the cosine graph. It continues on for infinity, both ways. One period can also be called one cycle of the sine curve graph. And the sine curve graph is symmetrical in respect to the origin, while the cosine graph is symmetrical in respect to the y-axis. And to find the amplitude of both the sine graph and the cosine graph, you have to find the absolute value of a in the equation.
Absolute value
of A.
That's right, friends. Absolute value of a. Alright, that's basically our session for today. I hope you've learned a lot. We'll take a brief commercial break, and we'll be back to talk about cosecant and secant graphs. Yay! Bye, children!